So if you take the sum of the lengths of the sides, we call that the perimeter. So if I were to take 3 plus 5 plus 6 plus 4, that's what we call perimeter. And so that'd be 10 plus 8, that'd be 18. And I would say this equals 18 units, but they tell me the measurement, so I say 18 feet. Now, how do you find the distance around a circle? There's a formula for that. It's called circumference. Circumference tells you the distance around the circle. We're not going to spend time on circles, but it is good review. The formula is pi times diameter, or 2 times pi times radius, and that'll tell you the distance around a circle. Other formulas you should remember. How do you find the area of a rectangle? Length times width. This is called a parallelogram. We're going to spend a whole day on parallelograms. How do you find the area? You take the base times the height. Notice height is straight up and down. How do you find the area of a triangle? You take base times height divided by 2. Or a triangle like this, it's base times the height that goes straight up and down divided by 2. Area of a circle is pi radius squared. Trapezoid, you have 2 bases, base 1 and base 2. You add those together, multiply by the height, and then divide by 2. So we're mainly going to be focusing in on rectangles and triangles, but make sure you're familiar with all of these formulas. And what our objective is today is we're going to be calculating perimeter and area on a coordinate plane, and you need to know the side lengths. Now, if it's straight horizontal or vertical, you just count. To find lengths that are not horizontal or vertical, you're going to use the Pythagorean Theorem or the distance formula, which are the same thing. And you can find I copied and pasted the distance formula. So, first example, let's say you have a triangle. How do I know it's a triangle? The symbol says triangle. And we have A, B, C, and these are the coordinates. So first thing I need to know is how to plot coordinates. So A is at 2, -1. That'd be right here. There's A. B is at 5, -1. 1, 2, 3, 4, 5, -1. And C is at 5, -5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And technically I should label this A, label that B, label that C. Now notice this does make a triangle. If I connect A to B and B to C and then C to A, I get a triangle. Okay? Now, it's easy to count horizontal, it's easy to count vertical, it's not as easy to count diagonal. Anytime you need to count diagonal, you use the distance formula or Pythagorean theorem. But from here to here, and I'm going to go ahead and label these A, B, and C. So if I'm finding the distance from A to B, I just count 1, 2, 3. So from A to B is 3. From B to C, I go 1, 2, 3, 4. So I'm supposed to find the perimeter, and you may notice I'm not going to use the distance formula on this one. I'm also not going to use Pythagorean theorem because I recognize that if this is 3 and that's 4, that if you do a squared plus b squared you get 5. It's a Pythagorean triple. So I know that from A to C is 5. So when they ask me for perimeter, I just do 3 plus 4 plus 5. Which is 12. So I say 12 units. For area is equal to, on a triangle, you take the base times the height. So you take 3 times 4, which is 12. And then you divide that by 2. So you get 6. So I'd say that the area is 6 square units. That means if you were literally to count the squares, it would be 6 squares that would fit inside. You got 1, 2, 3, and then between the rest you get 6. 6 square units. Alright, given square ABCD with the given coordinates, what's the perimeter in an area? First, A is at -2, 2. So I go -2, 2. There's A. That's A. B is 1, 4. So I go 1, 1, 2, 3, 4. C is at 3, 1. 1, 2, 3, 1. And D is at 0, -1. That'd be here. So real quick, I say this is A. Don't need you to be that large. There's A. There's B. There's C. And there's D. And together, this makes a square. So, square, here to here, there to there, there to there, and here to here. Now, because they told me this is a square, this problem becomes much easier. It's a square. Because instead of using distance and Pythagorean Theorem 4 times to find AB, BC, CD, and DA, because they told me it's a square, I'm going to find it once, and then that tells me what each side is. Now you can use the distance formula or Pythagorean Theorem. I think it's easiest to use Pythagorean Theorem. So start with the point, and you're trying to make it into a right triangle. So if I go from here, and we could even do it, you could do it on the inside or on the outside. Maybe I'll do it on the outside just so it's less confusing. So I'm going to draw a line from here to here, and then a line from here to here. I could have also done on the inside, same thing. And now when I label it, I could count that this is 2 units. And this is 3 units. 1, 2, 3. And I could use a squared plus b squared is c squared to find the distance between a and b. So I'm using a squared plus b squared a squared plus b squared equals c squared. So A would be 2 squared, B would be 3 squared, and then I'd get 4 plus 9 equals c squared. 2 squared is 4, 3 squared is 9, 4 plus 9 is 13. Take the square root, and I get the square root of 13. So I'd get the square root of 13 equals C. And if you wanted to, you could type that in the calculator, or you could leave it as square root of 13, your choice. So if I go type square root of 13 in the calculator, I get 3.61-ish. So I'd say 3.61 equals C. If they want you to leave it as a radical, leave it as square root of 13, maybe as a decimal, okay? Now we can go answer the question. We know that this is 3.61, which means this is 3.61, which means this is 3.61, which means this is 3.61, because it's a square. So to find perimeter, I just take 3.61 plus 3.61 plus 3.61 plus 3.61, which is the same thing as 4 times 3.61. And I would probably just leave that as square root of 13 to get more exact answer. And that's 14.42 units. And then the area of a square, you just take length times width. So it'd be 3.61 times 3.61. Or you can leave it as square root of 13 squared. Which is just 13. If you type in 3.61 times 3.61, you get a little bit over 13 because of rounding, but it's really 13. So I'd say the area is 13 square units. Now we have a rectangle A, B, C, and D. We have the given coordinates 2, 2, A, 2, 8, 6, and 2, 6. So labeling my points. Labeling my points, this is A, that was B, that was C, and that was D. I connect my points to make the rectangle. So that says 90 degrees. This should say 90 degrees because it's a rectangle. It says 89.5. There's 90. That should say 90. Right now it says 74, 78. Should say 90. Almost 90. And then from here to here, it's 90. All right. Now this one's actually pretty easy because everything is straight horizontal and vertical, so I could just count. I don't need a formula. So from D to C is 1, 2, 3, 4, 5, 6. So this is 6. This one's also 6. That's one of the properties of a rectangle. From here to here, 1, 2, 3, 4. And this is 4. So when I add the perimeter is equal to 4 plus 6 plus 4 plus 6, which is 20. So I'd say 20 units. Now the area of a rectangle is base times height or length times width, however you want to say it. It's going to be 6 times 4. Which is 24. So the area is 24 square units. So given a rectangle, another rectangle problem, with A at 0, 0, that's the origin, B at 2, 1, C at 4, negative 3, 1, 2, 3, 4, 1, 2, 3, And D at 2, -4, notice this rectangle is going to be a little bit more work. Because it's going from here to here, I can't just count that very easily. But I do know that whatever this is, because it's a rectangle, those should be the same. And then, from here to here, I'm going to have to find that, and that should be the same as this. So I have to use the distance formula or Pythagorean theorem twice. Let's go up here and find this distance first. And I'm going to zoom way in to give myself more room. So if I make this into a triangle, I could go from here to here, and then there to there. That makes a right triangle, and I can use a squared plus b squared is c squared. This is easy to count, that's 1. This is easy to count, that's 2. So now I have to do the old formula, 1 squared plus 2 squared equals c squared, which is my hypotenuse. 1 squared is 1, 2 squared is 4, 1 plus 4 is 5, and so my answer is going to be I'm going to have to take the square root of 5. To get C. You can either leave that as square root of 5. I actually kind of recommend leaving it as square root of 5 myself. So you know that this is square root of 5. If square roots scare you, you could probably change it to a decimal, but I know that this is square root of 5, which means also this is square root of 5, because it's a rectangle. Right. Now I need to find the area of the purple, or the length of the purple. So I'm going to make a new triangle from here to here, and then here to here. If I count this way, that's 2. If I count this way, that's 1, 2, 3, 4. So then I do the Pythagorean theorem, 2 squared plus 4 squared equals c squared. You get 4 plus, and then 4 squared is 16 equals c squared. 20 equals c squared. And I honestly would just leave the answer as the square root of 20. If you don't like square root of 20, I would change that to a decimal. So square root of 20 goes here, and it also goes over here. So what we know so far is that one side of the rectangle is square root of 20. Again, if you don't like square roots, you could change that to a decimal. That's fine. But we know that this side is square root of 5, and this side is square root of 5. So let's find our perimeter. Our perimeter is going to be square root of 5 plus square root of 5 plus square root of 20 plus square root of 20. And I'm not even going to try to write that out. I guess I can. So the perimeter is going to equal square root of 5 plus square root of 5 for these two, square root of 5, square root of 5, plus square root of 20, square root of 20. Now technically you could reduce these and combine them and make it one simplified radical. One day you will do that. For now, I think this is enough. So I would just type this in your calculator. Square root of 5 plus square root of 5 plus square root of 20 plus square root of 20. And you get around 13.42. So I'd say the perimeter 13.42 units, approximately. Area is length times width. I have my length. My length is square root of 20. My width is square root of 5. So my area is equal to the square root of 5 times square root of 20. And I don't need a calculator for that because 5 times 20 is 100. Square root of 100 is 10. But in case you don't know, feel free to use a calculator. Square root of 5 times square root of 10. Oh, square root of 20 is 10. See, it's 10. So the area would be 10 squared units. If I counted up the squares in the rectangle, I'd get